Um, Good evening. Today we'll be discussing the angular acceleration. So, if you have a string and the string is where along a circular path, we can be able to calculate the angular acceleration and as well as the angular velocity. So we know that a linear velocity is giving us v is equals to the change in distance over the change in time, right? So now when we have an object being like we're in a circular path, making an angle of theta, where here r is the radius and here is where's it? So now we know that x, which is the circumference of the circle, is pi over 360 times 2 pi r. This is an important equation. So we know that 2 pi is the same thing as 360. So now x is the same thing as delta 2 pi times 2 pi r. So this can take care of this. So we can have the circumference distance maybe what r delta, which we can call our equation 1, 2, 3. So now recall that angular velocity is equal to theta over time, and linear velocity is equal to distance over time. So when you divide equation 1, 2, 3 by t, so you have x over t is equals to r theta over t. You can now rearrange it as x over t is equals to r times delta over t. So now since you know that distance over time is linear velocity, and the angular delta over time is angular velocity, therefore you can now write v is equals to r, the angular velocity. So now this is the velocity for an object in a circular path. So now you know that acceleration is giving us the change in velocity over change in time. So I can continue from here. So since the acceleration is equal to change in velocity over change in time, I will know that the velocity, linear velocity, is equal to r, the angular velocity. Then the acceleration will become delta r over what? The change in time. So now you know that the radius from here to here is the same thing as radius from here to here, and the same thing as radius from here to here. So acceleration will now become r over change in time, same thing as change in angular. And you know the change in angular velocity is the same as w2 minus w1. So therefore the acceleration is giving us r over change in time, w2 minus w1, or the acceleration is equals to r over change in time, which we can now rewrite as the acceleration is equal to r change in angular velocity over change in time, where angular acceleration is equal to change over change in t. That is, angular acceleration is given as change in over change in t. Then the linear acceleration is equal to r times the angular acceleration. This is the linear and this is the angular. So this equation more like connects the linear acceleration to the angular acceleration. Thank you.